The question says which one of the following arrangements of molecule is correct on the basis of their dipole moment. You can see in the options 3 molecules are given there in the random order and we have to determine their dipole moment. Always keep in mind a molecule in which the central element is having regular geometry determined by hybridization. If the regular geometry is there, its dipole moment will always be 0. Okay, for example, you can see 3 compounds we have. From any option we can take these 3 compounds. BF3, NH3, NF3 is there. Let me write it. This is what BF3. Next we have NH3 and then we have NF3 is there. NF3. I am talking about BF3. In this case, boron has how many valence electrons? 3 valence electrons. And it is using all its valence electrons for the bond formation. Then it is forming 3 sigma bond. Okay, because fluorine will always form single bond. Then hybridization will be sp2. And if hybridization is sp2, regular geometry we are getting trigonal planar. And a regular geometry is there for this dipole moment is 0. Good. Next point. You can see if we go for these compounds, in this case you can see nitrogen is the central element and in each case nitrogen is forming 3 bond, means in each case nitrogen is having 1 lone pairs. And always keep in mind in a molecular compound if the central element is having lone pair, dipole moment will not be 0. Okay, polarity will be there. Polarity will be there. Dipole moment will be 0. But nitrogen same, number of lone pair also same. So from the central element we cannot determine the dipole moment. Then we have to take help of the substituent group. Anyway, in this case nitrogen is forming 3 sigma bond. It is having 1 lone pair. Total number of sigma bond will be 4 sigma bond, because in hybridization we take 1 lone pair is equal to 1 sigma bond. Total 4 sigma bond making 3 plus 1 is equal to 4 sigma bond, and it is making what? Tetrahedral geometry. And now we have to place this lone pair over here. If I hide it, it will be having pyramidal shape. Here we have the pyramidal shape is there. Pyramidal shape. Okay, it is having pyramidal shape. Same is the case. In this case also, 3 sigma bond, 1 lone pair. Total 4 sigma bond. sp3 hybridization. Then it will be having tetrahedral. If you place the lone pair, it is also pyramidal. Both are pyramidal. Okay. We have nitrogen. We can draw the structure. This is hydrogen. This is hydrogen. And this is hydrogen either, and this is the lone pair either. In case of NF3, nitrogen lone pair will be always at the top, and this is F is there, this is F is there, and this is what F is there. Okay. Now we show the dipole moment based on electronegativity. Nitrogen is more electronegative than hydrogen. Nitrogen is pulling electron density, then dipole moment is going from hydrogen to nitrogen. Here also dipole moment, and here also dipole moment is there. And always keep in mind, in case of lone pair it always moves upward direction, because we always keep lone pair at the top of the central element. In this case situation is different, because fluorine is more electronegative than nitrogen. It is pulling electron density. So you can see dipole moment goes like this, and in this case dipole lone pair is there, so dipole moment will be going upward direction. Okay. If you look at the ammonia molecule, in this case all the arrows are going in one direction. All these arrows are going in one direction. In this case you can see dipole moment is increasing. The magnitude of the dipole moment is increasing. Dipole moment will be much higher, because all these arrows are adding up. The strength of the dipole moment, the magnitude of the dipole moment is increasing. I am talking about this one, NF3. In this case you can see one arrow going upward direction, and in this case just opposite to this arrow is going other direction. Anyway, they will not cancel out each other 100%. Why? Because this dipole moment is different, and here we have the electronegativity difference. Some cancellation will be there, but 100% cancellation will not be there. If we have the situation like, let's say this is N is there, this is F is there, and then we have F is there, something like it there, then we can say these arrows are going opposite to each other, against opposite to each other, then we can say dipole moment will be 0. If these arrows are coming in this case you can see they are going other side, they are coming against each other, in this case also dipole moment will be 0. And it is possible when the electronegativity between the two atoms is same. If the electronegativity between the two atoms is not same, dipole moment in this case also will not be 0. For example, let's say if I talk about CH2 and it is Cl2 is there. CH2 Cl2. Okay, so in this case dipole moment will not cancel out 100%. Okay, some cancellation. In this case you can see dipole moment is adding up, magnitude is increasing, but in this case somewhere it is cancelling out because these arrows are opposite direction. 100% cancellation is not there. Dipole moment is there and lone pair is there. Obviously dipole moment is there, but 100% cancellation will not be there. So we can say ammonia is having higher dipole moment than NF3, and in this case it is dipole moment is 0. So what is the order we are getting? First we have NH3, then after that we have NF3, and then we have it is BF3 is there. Very interesting question. Why? Because we determine dipole moment based on geometry, and in this case we did not determine the dipole moment based on lone pair. Lone pair is there because lone pair is same over the same central element. So in this case also we find the geometry, and then we based on the electronegativity difference we determine the dipole moment. Okay, NH3, NF3, BF3, any such option, NH3, NF3, BF3, option D is correct. We have option D is correct. If you like this video, please share and subscribe to the channel.